As part of NASA's exploration program, Americans are returning to the Moon, then to Mars, and beyond. One of the many things that we learned from the Apollo program is that going to the Moon is excitement in epic proportion. Something else we learned was the importance of paving the way with robotic spacecraft. With names like Ranger, Lunar Orbiter, and Surveyor, they taught us a lot about the Moon, making possible Neil Armstrong's first, historic, and humbly self-proclaimed small step.
And that may have been a small one for Neil, but that's a long one for me.
By the second of the 6 missions, during which 12 Americans explored the lunar surface, the astronauts came in direct contact with their robotic heritage.
I can never believe it. Look what I see sitting on the side of the crater. Real surveyor, yes sir. Does that look neat?
It made sense to send robotic pathfinders then, and it makes sense to do so again as we prepare to send astronauts back to the Moon. There is much that we know about the Moon, but there is more that we must learn before we return, this time to set up outposts. That's where the Lunar Precursor Robotic Program comes in, leading the way back to the Moon.
Hi, I'm Tony Lavoie with NASA's Lunar Precursor Robotic Program. Our journey back to the Moon starts here. I would like to take you on an important upcoming mission that will tell us more about the Moon than we've ever known before. Ames Research Center and Northrop Grumman. Now, imagine it is late 2008. We are at Cape Canaveral and our Atlas V launches our pathfinding mission skyward. We build up speed as we roar through and out of the atmosphere. Everything checks out, and the Atlas upper stage boosts LRO and L-Cross toward our closest celestial neighbor. The trip takes about 4 days. As we approach, LRO separates. This is where it and the L-Cross with the upper stage go their separate ways. LRO works its way into a low circular polar orbit, the lowest lunar orbit ever. It will only be 50 kilometers or a little more than 30 miles above the surface. This is a great vantage point for its year-long fact-finding mission. It will map the Moon with high-resolution imagery as well as a host of other data collection instruments. As LRO starts its mission, L-Cross and the spent upper stage get a speed-building running start for what will be an exciting impact on the Moon. They slingshot around the Earth a couple of times, then hurtle toward the lunar surface. Just a few hours prior to impact, the combined upper stage and L-Cross separate so that the L-Cross spacecraft can watch the upper stage impact. With L-Cross instruments watching, the Atlas upper stage will impact a permanently shadowed crater on the Moon, where we might expect to find water ice. This impact kicks up a major dust cloud or ejecta field. L-Cross analyzes that moon cloud, telling us what the crater's surface is made up of, and hopefully what can be farmed later to support outpost activity. After that impact, the L-Cross spacecraft then hits the Moon as well, with a smaller impact because of its smaller size, but still visible from Earth-based telescopes and possibly LRO to look at the ejecta cloud. Meanwhile, LRO continues its mission of discovery. This is an exciting and ambitious mission. It will generate volumes of data that we will closely analyze. That new knowledge will make future human exploration safer and more efficient. These are exciting times, and I invite you to follow our progress on this mission of exploration as we lead the way back to the Moon.